Our proposed carotid prosthesis embraces physical computing and anatomical expression to create a dialogue between technology and nature. The human cervical region, the area surrounding the neck, has been celebrated by historical and contemporary fashion trends alike, either through concealment or elaborate exposure, tailored garments, and accessories. For example, the ruff or turtleneck have been used since the 16th century with diverse connotations throughout particular historical moments, denoting aristocratic provenance or political orientation. This project aims to reimagine this bodily area within current technological discourse on responsiveness through a ruff-like prosthesis which extends aesthetic preoccupation to consider thermal comfort scenarios and explore how these can manifest visually. Our premise stems from the traditional neck ruff, which evolved from a small neck piece to larger and more elaborate collar pieces during the Elizabethan era. This proposal considers garment as a vessel for human thermal adaptation. Interestingly, body temperature, amplitude, and patterns correlate to standard biophysical incidences such as heart rate and respiratory rate, as well as emotion.
Although we have tried to approach the project as an idea investigation for a new wearable piece, we are by default concerned about the performance relative to the available technologies. While several design decisions have been driven by aesthetics or ergonomic preoccupations, others are clearly guided by performance constraints relating to the control of the fluid and other factors. The design includes a microprocessor, a sensor, circulation control system, heat regulator, and a wearable enclosure. A pulses sensor reading from the carotid artery is used as a control logic for a peristaltic pump that circulates a fluid medium in a closed-loop tubing system with an inline heat exchanger that can either collect heat from the body or the environment. So the integration of these components within a wearable item carefully considers minimum weight and non-disruptive presence on the user. Soft materials like silicone rubber and flexible resin are employed, combining laser cut and 3D printing.
The control of heat transfer is the principle of the design of the thermo-regulator. The silicone rubber serves as a primary layer holding a soft 3D printed layer, securing the liquid tubes. To ensure skin breathability, a pattern of holes is cut from the silicone surface, using a parametric definition which translates color data from thermal infrared imaging of user's cervical area into a gradient pattern. The effect resulting from the transformation of thermal data into graphic becomes an inherent ornamental quality of the piece that is draped onto the neck, chest, and upper back areas. It provides a clear reference to the internal blood vessel network of the neck. The draping is designed to reveal the network of tubing containing heat transfer fluid as well as conceal inline heat exchangers. Studies have shown the relationship between the heart rate and the body temperature. Therefore, the team incorporates a heart rate sensor as a body temperature indicator. The draped silicone sheet secures the heart rate sensor and tubing, and is attached to the draped silicone sheet via a number of buttons and a feather-like barb ties. The drape sheet becomes a base for attaching customizable ties. In addition, we explored different methods of integrating a pump into the garment. In one of the designs, the pump is integrated into the 3D printed layer. In order to remove attention from
the design and fabrication of the prototype revealed a series of criteria that can be further addressed towards our intent of creating a piece that is efficient and market-ready. These considerations include a maximized surface contact area of the liquid with the body, a closed system for the heat exchanger, adequate and autonomous power to run the pump, as well as mapping of the heart rate values using a Schmidt trigger, and pulse width modulation, so that the current on-off control of liquid flow may be substituted by a range of values permitting variable flow speed. While all these factors are technically warranted, their optimization can inherently augment the prosthesis' role as a fashion statement, celebrating the importance of the cervical area as a liaison between the central body organ, the heart, and the body's processing unit, the brain.